Hi everyone, I'm back again with the next episode of recording setup. We've covered a little bit about interfaces and connections and what you need: digital audio workstation interface, microphone, loudspeakers and or headphones to listen back to the recordings on, or hardware recorders. You could use portable, or some of the hardware standalone recorders, the way you don't need a digital audio workstation, or you could use a portable recorder in conjunction with a digital audio workstation and import the files into there and work on them, and also it depends on cost as well, how much money you've got. And so, you don't need to spend loads of money, because if you're starting off and don't know much, it wouldn't be worth spending heaps of money if you really. Although you can kind of, like with interfaces, you can, let's just say if you're talking about like the Focusrite Scala interfaces, they're sort of real budget end. You can get like the Focusrite Claret, a little bit better quality. I suspect they've probably got slightly better converters, which I will talk about in a little bit. And then they'll have better preamp. So you can, it depends how much money. You could sort of go a little bit up if you want to, if you've got enough money to spend. But otherwise, you can stick with the budget. You've got Audient, ID22, ID14 they do the ID4, it's even cheaper. The ID44, that's got 4 inputs. They're very well reviewed bits of kit, the Audient as well. So, and then you've got, I did notice as well, I looked up recently, the Apogee Boom, and I think that's a 2 input. I think it's 1 mic input, and it's got I think you can have a jack input into it, another, something like an instrument probably. And their preamp's probably much the same as anyone else's, but they might have slightly better conversion on that little unit, because they are well known for their converters, Apogee. So, anyway, so you've got the interfaces, you've got the hardware stuff, and I think I'll come back to that in a minute. I'm just going to talk about the recording process, and then I'll come back to the interfaces and some other stuff, maybe a little bit of technical info that is really useful to know, sampling rates and things. So recording process wise, when you've got your stuff set up, you might wonder, how can you, let's just say you want to record, let's just say you've got Didgeridoo. If you're just recording Didgeridoo, one solo Didgeridoo, you just need one microphone input on whatever you've got, whether it's an interface or whatever. So you could have a single, get the cheapest interface with a single microphone input. One microphone input on the Apogee Boom is one, you got one mic input on that with another different input. So you could use that and then just record one solo bit of digging, keep it that simple. But if you want to, let's just say you want to, you think, well, actually in the future, you might want to record one didgeridoo, or you might want to do didgeridoos. And let's just say, how can you do that if you buy a single microphone input interface? So you've only got one plug you can plug in. How is it possible you could record several tracks with just one mic input? Well, this is where overdubbing comes in. And this is why you only need a 1 or 2 input interface, because you only need, let's just say you had a 6 microphone input. You only need that really if you're playing 6 instruments at once. So if you had like a little band all playing together, that would mean 6 inputs. But you don't need it if you're doing your own stuff and you only need 1 or 2 maximum inputs. If you can get by with 1. So how does that work then? Basically, what you would do there is you've got everything plugged in. You've got your mic into your interface. You've got your DAW ready, or you've got your hardware mixer ready, or you've got your portable recorder ready, and you just press record, and it's going to go through, right? And it's going to record, and you stop it, and that's that. So now let's just say that this would apply more so for the hardware mixer recorder, like I showed you the Tascam S3 or whatever it is, 03. and the other versions they do, the more elaborate versions, or in the DAW. Let's just say you want to record a drum with it. Let's just say you've got a drum machine and you just want to have a bit of a beat. You'd probably record the drum beat first and play to the drum beat. So let's just say then you've got a drum beat and you've recorded that through, let's just say you've got one microphone, one input on the interface. You could record that into your DAW or on your hardware, and then you could overdub the didgeridoo on top of it. So that, in other words, you could record, say, 3 minutes of the drum, and then you'd go back and replay that. You'd press the play button in the DAW or on your hardware mixer. You press the play and record at the same time. I mean, in your DAW, you might just press record, whichever way that DAW works or the bit of hardware works. So you press record, and it will play the drums back whilst you can record your didgeridoo. So that's what overdubbing is. In other words, the drums playing back, you can hear it through your headphones, and then you can then play your didgeridoo to that drum, even though you've got one single mic input. Now, it would be better to have, if you had like a drum machine and a didgeridoo, it would be better to have two microphone inputs on the interface, because rather than having to plug your microphone into that same one you've just plugged your drum machine into, then you can have two input. It could be that if it's got a jack input and just one mic input on the interface, that would be fine, because then you plug the jack input in from your drum machine, and by having two inputs, it just means you haven't got to plug one in and take it out and then plug the other one back in. So as long as you've got two inputs, you could do a drum machine. It doesn't need to be two mic inputs. It can be one mic input and a jack input, a line level input, and so that way, that's why two inputs is often quite handy, really, two input interface. So that anyway, so overdubbing, you can play back and record at the same time, and you can do as many tracks as you like. This is like tracking, where you're recording onto tracks. You could record other things, or you could record the didgeridoo, another didgeridoo, and play like two digis. So you've got two dig tracks and a drum track just through the same interface. You haven't got to plug anything in and out. You just have it routed on your DAW or on your bit of hardware with the incoming signal from the existing microphone. So, I won't explain everything about connections on that, because if you've got a two input interface, you've only got to connect it in and then have it routed inside your DAW. Or inside your hardware. Often you can route it in your hardware as well. So that's how you overdub. And basically you would, when you're recording, you want to record on headphones and listen to it while you're playing, and not through a pair of loudspeakers, because the loudspeakers would feed back through your microphone, which is why headphones are useful. Because if you've got your headphones on, it's not going to bleed through, the sound from your headphones is not going to bleed back through your dig mic when you're playing your didgeridoo. If you're not quite sure overdubbing there, I'll give you a brief idea how you can do it. You can look that up more to see what that's about, to get a better understanding of it. But I'm just giving you a rough idea, just to show what you can do and what interface you can get, basically. And then, if you record into your digital audio workstation, if you let's just say you wanted to record two dig tracks, one on the left channel and one on the right channel, and the drums down the middle. That's you'd normally have your bass drum down the middle, and let's just say you wanted to do that, and you can overlay other tracks. You can overdub other tracks. You could have up to as many as your DAW will allow you to. And then let's stick with the three. So you've got your drum track, you've recorded down the middle, and then the pan control I talked about on the first video about recording, that pan control where you turn it left and right, you can place, because when you're recording it, you can just record it down the middle. It'll just be a mono channel, your Didge. And if you've recorded 2 separate mono channels, as Didgeridoo, you can then pan them, one to the left and one to the right, as far as you want, to get in your stereo field. You can pan them as wide as you want, so that when you're listening to them, they will sound like they're coming further, in your left and right ear. That's how you get stereo soundstage, basically. And then you've got your drums down the middle, and then you've got a stereo soundstage. And then, as I say, you can overdub, do this, build tracks up, record, pan them wherever you want. You've got to get your levels right. I can't really discuss going into the levels completely here, because it's a little bit to talk about on that. But just very basically, you get your levels right, and from your gain, from your interface, you want to get your gain set up right so that the microphone signal's amplified, and then it comes into the DAW or the bit of hardware. And then once you've got the levels right on there, don't forget if you had a mixing hardware desk, you'd have the gain on there. That would be your interface. So, because they're digital mixers, not analog. And that's the other thing to consider, is in the old days, it was all everything was recorded on analog. There wasn't digital. So the hardware mix, the hard bits of hardware mixers, when I showed you that hardware mixer on the previous video online there, that Tascam Model 12, that's actually a digital mixer. But in the old days, those mixers with all those knobs on were analog. Analog meaning that the signal coming in the microphone, when you play in your Didge, or if someone's singing or whatever it is, the microphone signal is maintained as a waveform, and it goes through into the mixing desk, and all the controls on there are controlled via analog. It's controlling the analog signal. Everything's analog. When I'm speaking, it's an analog waveform. It's recorded as a copy analog, and it was recorded onto tape in those days, and it was also recorded as listening device. It was recorded onto vinyl or cassette tape. That's if you can remember those days. I do, because I'm a bit older. So, but if you're really young, you could look it up and see what that was all about. But these days, what we've got is digital. So what happens is, I will explain a bit more about that in a minute, but basically the digital is the analog signal from your microphone is converted into digital, and then when it goes back out through the speakers, it's converted back to analog again, because we hear in analog, and the loudspeakers are analog, and the headphones are analog. So basically what's happening is, let's come back to the interface. When you've got this interface, inside your interface is a preamp. So the interface that's plugged into your computer via the USB, inside the interface is actually a preamp as well. And you think, well, okay, what's a preamp? It's an interface. What's a preamp? Right. You can get separate preamps, you say. You can get separate preamps. A preamp is basically a preamplifier, a microphone preamplifier. And what that does is, so have I still got that? Oh, I've got that here now. That microphone I showed you, or any microphone, dynamic or condenser mic, or ribbon mic, or whatever microphone you've got, when you play your didgeridoo through that microphone, the signal, the sound wave, hits the microphone, and it gets converted in the microphone into an electrical signal. It's a tiny little electrical signal. And through the cable, through the wire, that little electrical signal goes all the way down the cable, through the XLR lead and into the interface. And in terms of volts, it's tiny little voltage, That's what we refer to it as like a voltage, voltage and current. But it's just a tiny little voltage, and by the time it gets to the interface, it's too small to do anything with. So that gain knob on the interface that I showed you on the previous video, or on your bit of hardware, that gain knob or trim knob, you turn that up to boost that tiny little weeny voltage of a signal from that microphone, and you'll get a smaller signal from a dynamic mic than you will from a condenser mic because they're powered. So they will give you more oomph from that. You'll turn the gain up less on a condenser mic than you will on a dynamic mic, which is why some mics need an extra amp. Like I think on the Shure 7, Shure 7B or whatever it is, I can never remember the names of these things. They're called a cloud lifter because it gives it extra boost. Because if your interface can't boost the gain up without making noise, then this cloud lifter comes in handy. It gives it that extra lift. So in that interface is a preamplifier, and it's like a separate part of the interface, and it's boosting that signal so that then it's boosted to what we call line level, a slightly bigger voltage, up to a volt or so, 1.23 volts, professional level, it's bolted up. It won't be that because it depends on the mic signal and what that's boosted, what line level that's boosted up to, whatever voltage that is, and that will then go through the interface and into the door at a higher level rather than because the mic signal's too low. Hope that makes a little bit of sense. So anyway, it's boosting it. So that's the preamp interface built into an interface. Sometimes you get external preamps that you could plug into your interface. And then, there's that way of doing it. If you buy an external preamp, usually you're going to be buying a better quality a preamp, because one inbuilt, certainly inbuilt in a budget interface, isn't going to be as good as an externally, if you buy an external preamp to it, and you've got to connect that up. But anyway, you've got it in an interface. If you're just starting off, you get yourself a interface. It will have a preamp built into it already, and then after that you've got you need to think about, so once you've got everything connected up and you've got the level into your door, after you've turned the gain up, you've got this level. You'll see in your door, you'll see this signal level going up and down on a bar meter, what we call on a peak meter. You'll see this level, and basically you want to make sure that stays below 0 dB. When I'm recording into something like a digital audio workstation or even a portable recorder, I never went over minus 12 dB. Minus 12 dB, you will come across this term decibels. dB stands for decibels, and it's always minus because 0 dB is, you don't want to be going over 0 dB because it starts clipping. So if you do record and you record to somewhere where it peaks, the peak signals, the bar, don't go above minus 12. Particularly, I wouldn't go over minus 10, but mine would say I don't like them going over minus 12. Then you'll be fine, so, because otherwise if it starts clipping, digital distortion sounds terrible. It's not like analog distortion. It's in the old days where the analog distortion is much more passable, and it can be used, but digital distortion isn't good. So you want to make sure that when you're recording, you set up. I'm just giving you a basic idea because, as I say, there's too much to go into, but it gives you an overview. It gives you an idea how to think, okay, get it set up basically, and keep your levels to, once it's in the door on your piece of hardware, so it's not going above, say, minus 12. Use that as a rule. You can boost the levels up later, you see, to get them to the right level. So that's that. Talked about overdubbing, how you can record in your room. If you're going to set up a spare pair of speakers, small rooms tend to be a lot worse than big rooms. I've recorded in the past and done professional recordings in a larger room with virtually no acoustic treatment, which isn't easy to do because the reflections in the rooms from when you're recording can be a real pain, you know. And in this room in particular, you can see behind me there, I've got some panels on the walls. I've got some panels around the side of the walls and at the back, because I'm in a small room here. The room is actually not fantastic to record in without those panels, so I've had to put them up. And you can make yourself cheap panels or get someone to make them for you if you want to. It would be helpful if you're going to have loudspeakers or speaker monitors, because when you're recording, you can get away with more if you position your microphone right with the Didge, which I've done a video on. You can look that up if you want. Without panels, if you're very careful, there's, you know, and you use the right mic, it's doable. You can get around it somehow. But when you're listening back, if you're doing what I call monitoring and listening to recordings on playback, it's hard to listen to the stuff if you've got your room being muddied, the playback and your listening being muddied by the room sound when you're recording. So keep that in mind, which is why you might want to think about, you know, either getting a pair of headphones or just getting a slightly better pair of headphones to counter that. So that and in the future, when you're listening, because as I said, you've got this stereo sound field, you've panned the things in a particular place, you can need to get your levels right coming in, and then when you've recorded the incoming levels, say at -12 dB for safety's sake, peaking, when you've got all the tracks, you know, inside your DAW on your hardware, you can then, when they're recorded, you can then use your faders or change the levels and boost them where you need to. And in the future, I'm just going to briefly mention this. In the future, to get the levels right, you need to push the levels up. I mean, we often use we will use a limiter for that. It's what's called a limiter, and so you can use that when you're getting, you know, when you're mixing, what we call mixing down. So if you've recorded a few tracks, you've played back and overdubbed and recorded more, you then at the end sort of start mixing down. You get all the tracks. Let's just go with the 3 tracks. You've got the 3 tracks there. You've panned them in the right place. You've got the levels. You've got the drum level right on the fader. You've got the 2 Didge right and left. You've panned them, and you've got the levels right on the fader where you want them. Right. So you've got 3 faders there. You're moving, and then you mix them down. You're mix them down to a stereo track, basically. You know, everything's mixed down to a stereo track. Forget surround sound for a minute. We're just talking about stereo. Because if you're listening on headphones, it's stereo. If you're listening on loudspeakers, it's going to be stereo, a pair of loudspeakers. So when you mix down, you're mixing down to stereo, or you know, you're going to bounce down to stereo. So basically, that's what you need to do there. So in the future, so once you've bounced down to stereo and you've pushed, you know, you might have pushed the levels up a little bit. I'm not going to talk about any other plugins that you can use, because there's lots of things you can do and that you need to edit. In the future, when you get used to recording, you can then learn to edit the audio in there. If it's got pops, crackles and things, you know, if you've got noises in there that you don't want, and sometimes in PCs you can get noises you don't want because of this, not necessarily just the CPU. It could be the way the PC works, where it's drawing certain things and utilising various tasks. It can actually cause little pops and things. So you might want to edit those out, you know, and in a DAW you can do it much easier than you can on a bit of hardware. That's the beauty of that, being in a DAW, you know, on a PC and a computer, using Studio One, Pro Logic or Mixcraft or whatever it is. And so that yeah, so there's those things to take into consideration, and you got to think what level you want to be with it. I mean, I'm quite fussy with my audio, and you know, I've done sound engineering as well, so you know, I like trying to get a really nice sound. So I've paid a bit. This is actually the first place I've been in where I've been able to get a few panels up on the wall, rather than having to be extremely, even more careful about, mic positioning and things, which I have done in here. I've still got my mic positioning. It's taken me some time to get it in here because of the room I'm in, and even with the panels. So it is a fiddly process, but you got to think, where do you want to be? If you're not bothered about getting really ultra pro audio sounding, recordings, and you just want something basic, and then you haven't got to worry about all that. Maybe just get yourself a pair of headphones, even just get a portable recorder, whatever it is. It doesn't really matter. It depends what you want to. It depends where you want to get to, I suppose. Really, if it's just as a hobby. If you ever want to get music out online, like onto platforms, and you want people to listen to it, you have then got to think, well, you need to look at the professional side, because you'll be in competition with other people, and if your audio is not good enough, then people might not listen to it for very long, because I think, oh, that doesn't sound very good. So you do then need to think, you want to get the quality of the audio, and you can certainly get good enough quality audio on a bit of hardware kit, and you obviously got much more power in the DAW as well, as I said earlier. So there's that. Now the other things to remember are right, so the one thing I haven't mentioned, I mentioned about interface preamp. You've got the signal coming in, which is an analog signal, waveform. It's like when you look at waves in the sea. It's not exactly the same, but waveforms travel through the air, and they go through the equipment and end up into the digital audio. Now, how do we get that into digital? Right, so you've got an analog waveform. This is where the converters come in. In digital audio, you need an ADC to get it into digital, an analog to digital converter. So the analog waveform comes through into your interface, through the mic, down the lead, into the interface, this little waveform, analog waveform, and then it gets converted, ADC, analog to digital converter, it gets converted into digital. So now we're in the digital domain, basically. And then it will stay in the digital domain when it gets into the computer, because via the USB it will be transmitted via digital into the computer via a USB lead. So, and it stays digital in the DAW. It's all operated in digital. When it comes back out of the digital audio workstation, and then it goes back into your interface, and then it plays out from your interface to your loudspeakers or through your headphones, it then needs a DAC, a digital to analog converter, to reconvert it back into the analog, because that's how we hear we hear analog waveforms. So that's what's going on there. That's what a converter does. If you've got a hardware mixer like the Model 12, the Model 12 is a bit more complex than some of them. It's a digital mixer, but it's an interface, and basically it does the same thing as an interface. It does the same thing. It's got a ADC and a DAC to reconvert it back for listening and monitoring. So you've got analog into digital, and then digital back into analog, so we can hear. And in the old days, as I said, they were recorded on tape recorders. It was all analog. There was no conversion needed. So when you're looking at interfaces, I did say that you can get better interfaces. I mean, you can get better preamps, separate ones. You can get better interfaces that have got better built-in preamps in them, and you'll just pay more. Pay £1,000, you're going to get a better unit, and you're going to get better converters. And then you've got dedicated converters. So basically, you've got if you go down, Apogee, I'm just going to mention one brand. They do converters that are have renowned converters. You can pay couple of thousand for these dedicated bits of kit. You can spend an awful lot of money, and mastering engineers in particular do have to spend a lot of money, because their mastering is the final process of that. You've got a mix down, recording, and then it gets mastered. And mastering engineers in a studio have to have really top quality top quality listening equipment and mastering equipment, because they are the guys, you know, and you might do mastering in the future for yourself. You can do it. You know, I do my own mastering, and it's got to be, you don't need that level of equipment. But if you've got like main recording artists that want their music at the top level, they've got to have high level equipment for listening, studio monitoring, top level conversion, because conversion does make a difference. And I mean, at budget level interfaces, you don't really need to worry too much, because it's going to be pretty much the same. But as you go up, yes, it does get more expensive. And on the I think the Apogee have got they've got the Apogee Symphony. I think they've got really good reviews, but it's, you know, what is it, £1,400, whatever it is. It costs a lot of money, but it is an interface as well. And yeah, you know, you don't need to worry about that. I'm just telling you so that if you're thinking of your own recordings in the future and it went to a mastering engineer, they'd have this top quality equipment. You know, if you wanted your music to be mastered, they'd have this top quality gear. But for, you know, for starting off at the budget end, you don't need to worry about that. But I'm just explaining conversion, so I just mentioned it at the same time. So you've got all the conversion, and then you've got and you've got sampling rates. I haven't mentioned that yet. Sampling rates. You'll come across, when you're recording, you'll come across sampling rates. You'll come across like 44,100 hertz is one. I'll just use kilohertz because that means 1,000. 44.1 kilohertz sampling rate, 48 kilohertz sampling rates, which is often used on video recording stuff, and 96 kilohertz rates. And there is higher, but really you don't need to go above 96k. You can record at 44.1, you can record at 48, and you can record at 96, and you should get top quality recordings on all of those settings. There are some engineers that actually prefer to record at 44.1, while others prefer to record at 48, and others record at 96. And you're talking about listening. You know, a lot of them will prefer one setting, even though it's a lower setting, 44.1. Don't get too caught up. You know, you can get top quality recordings at 44.1. And the other thing is bit rate, 24 bit. A CD, if you play a CD, it's 44.1 kilohertz sampling rate at 16 bit. That's what CDs are. So when you're recording in your DAW, most of us recording 24 bit, and then use either those three sampling rate settings. I'm not going to go into which one you should use. It's up to you. I've recorded I have recorded 96 and 40. I was using 48. I've just gone back down to 44.1 now, but you're going to just have to decide what you use. But anyway, that's what that is. The sampling rate really is like samples of the analog waveform, you know, 44.1 kilohertz sampling, you know, so it's a lot of snapshots of that wave, and so it can, you know, and it converts it, it samples it, sorry, yeah, and then it goes through the conversion and converts it, and that's what that's all about. So just to give you an idea, you know, you don't need to think too much about this, but certainly when you're putting it onto platforms and things, you kind of need, or when you're setting in your DAW, you need to know what you're setting at. So, or on your hardware, you know, are you going to set it? You got 44.1, 48, or 96, and if you were recording down to if you were recording, say, at 96k in your DAW and you were putting it onto a CD, you then need to dither it down. Dither's another thing. I'm not going to go into that, but there's other little things there. But yeah, mainly when you're recording and you're putting it online, you'll be using those sampling rates. So also, when you are, if you were ever to translate it into online, you've got, like, you've heard of MP3, and that's like a compressed version, and there's different formats where the music gets compressed. So when you're recording on your DAW or you're recording into hardware, you record at what we call a WAV file, which is not compressed at all, and you want to keep that high as quality as possible. And I think that's PCM, pulse code modulation, the WAV form. That gives you the highest quality. So you then, if you're uploading it to wherever it is, your audio distributor or whatever, it's best to keep it at its highest format, and then it will change it to whatever format they use. That's the best way of doing that. And also you've got levels and things. I'm not going to go into that here, what levels are, but that also comes down to what you're going to master the level at. And you can do that for yourself in the future. I might do a video on levels and things at some stage, and how you can get to the levels. But hopefully that's given you some idea of, interfaces, the DAW, sort of a very brief, rough kind of overview of it, the process, and a little bit about the equipment and how it works. And once you get to learn understanding how the signal flows through stuff can actually make it so much easier to understand what's happening as a whole. Anything else I need to mention here? Yeah, I don't think so. I think I've covered everything. I just want to make sure I've covered the main points, really. So yeah, anyway. So if you haven't got the gear yet, and you're going to get something, particularly now, this time of the year, go out and get it. And if you're like me, some people like to read the instructions, go through everything. If you're like me, I prefer to, I might read some instructions as well, sometimes you have to, but I like to get stuff plugged in and get working on it, and that's often the best way of learning, get hands-on. If you can get and find an old analog desk one day, go into a store and get them to show you what it's about, it might give you an understanding of how signal flow works through a desk. And if you can understand that, it gives you an idea of what happens in a digital audio workstation. It can be really helpful. That's one little tip I would say. And I can't think of anything else. No, hopefully that's, as I say, hopefully it's giving you something. And I think that's about it, really. And good luck with finding some gear and getting to play with it and get used to it and practice your recordings and overdubbing. And the more you do it, the more the more familiar you get with something. It might look daunting to start with, particularly with the DAW. You've got all the different things. As I say, if you can understand one strip and understand one plugin at a time, and once you've got, how it's working through looking at the mixed tracks through to the mixer section. So one last thing. So when you're recording, one last sort of summary. When you're recording, you've got your mic plugged in and everything. You're recording, you're tracking. You're recording onto a track, into your DAW or onto your hardware or onto your portable recorder. You're recording a track, and then you might record another track and overdub, and you might record another track, and you might have a few tracks. And then when you've got the few tracks and you'll listen back to it, you'll get your levels right and your faders and things, and then you'll mix down. That's what I call mixing down. And you might mix down on a pair of headphones, or you might use a pair of loudspeakers, or you might use both. And then once you've got it mixed down and you've got a stereo file, you can then, certainly in the future, you can think about this. You can then think of, in the future, of how to get those levels right, you know, and master them. You can do really basic mastering and get your levels up there. It's really not difficult to do. As I say, I might explain that on another video. Yeah, that's and regarding mics and monitoring, I have done videos on it, so you can look that up, and I have done one on EQing as well, so you could utilize that in conjunction with what I've done today, and you might find that helpful as well. And anyway, I think that's it. Don't want to go on too long. Good luck with it, and practice it, get used to it until you become familiar, and you'll find it so much easier. And don't be overwhelmed by it all, and some won't be anyway. They think, what's all the fuss about? But some of you will, because it is a lot to learn. So start simply and go from there. Anyway, that's it for today.